Hello, guys. I am back today, and we are going to go over critics of LLMs. Hopefully, you guys can enjoy the video. So, let's go ahead and discuss some certain topics about critics of LLMs. So, follow me to the other slide, and we'll be discussing about LLMs and some critics about it. So here, the topic about this slide is the AGI hype and the misconceptions of it. Here is a peak AGI hype hit in the early of 2023 with ChatGPT 4, like you see here on the image, which was in March 16, 2023. It says five jaw-dropping things ChatGPT 4 can do with the can do ChatGPT couldn't. So here's massive claims were made, 100 times productivity, job loss, AGI in a few years, but unemployment didn't rise, and those predictions haven't played out. So passing exams does not equal competence. So let's rewind to early 2023 when AGI hype was everywhere. GPT-4 was just released. Bing Chat was called the Google killer, and ChatGPT had already gone viral. People were saying AI would replace software engineers, lawyers, and even doctors overnight. Still hasn't happened, but I think it could happen in the future. But we'll see how AGI um, advances over the years. All this because it could pass exams, right? So obviously people have used GPT-4 to pass exams, and it does pass them. But 1.5 years later, unemployment in the U.S. is actually higher. Clearly, passing an exam doesn't mean you could do the job. We were measuring AI skill in a way that ignored deeper understanding, and that's where the problem starts. Yeah, that's a lot of problems now that a lot of people use ChatGPT to solve their problems, and we're actually not actually doing hands-on on certain things, which it might cause some issues in the future. So, why LLMs aren't actually intelligent? Here on the left side, I have a diagram that shows a shallow network and a deep neural network. Obviously, it runs on a deep neural network, the LLMs. It has input layers, hidden layers, and obviously output layers that we have discussed on certain other videos that I put up on my YouTube channel. So LLMs use pattern matching, not reasoning. Okay, we discussed that as well. They're sensitive to phrasing and unfamiliar input. Generalization fails, change a variable, and the whole answer breaks. Skill does not equal intelligence. Okay, so LLMs just run on inputs and pattern matchings. So LLMs like GPT-4 or Cloud don't think, they predict. If your prompt sounds like something they've seen, they do well. But change a name or reword the question, and the system might fail. That's not intelligence. Intelligence is being able to handle the unfamiliar. What LLMs show us is crystallized skill, not adaptive thought. It's like memorizing the answer key rather than learning how to solve the problem. This is a fundamental gap in how we interpret AI capabilities. So, measuring true intelligence generalization. Intelligence equals generalization to new problems. Three key traits: fluidity, operational area, and information efficiency. Exams are poor benchmarks for machines. They weren't designed for this. Okay, so we're gonna discuss some certain things. So, what should we actually be measuring, right? That's our question. Generalization, the ability to solve new problems with little experience. There are three lenses here, okay? First, fluidity, the ability to create new solutions, not reuse old ones. The second one, okay, these are the second key trait that I'm going to be discussing here, is operational area. Can solve system can the system solve problems across a wide domain, not just close to what it's seen, right? And the third key trait here is information efficiency. How much data does it need to learn something new? And it does require a lot of data. And also, I actually read an article that just by saying thank you and please to the LLM is costing millions of dollars. So standard exams assume human priors and no prior exposure to answers, but LLMs have seen everything. So when they ace an exam, it doesn't tell us much about intelligence. It tells us they memorized the web. Okay, that's what it does. It gets all this information on the web and then it just starts putting it out there for you. So it's not like it's thinking itself to its with itself. The ARC data set, a better benchmark. Okay, so this is we played this in class and it was pretty interesting. It's actually entertaining. So ARC, abstraction and reasoning corpus, designed to test generalization. All right. So tasks are novel, can be memorized. Humans 97 to 100%. LLMs 5 to 21%. Okay. Program search uh, around 50%. Okay. So to really test generalization, we need something different. That's where the ARC dataset comes in. Each problem is new. Memorization won't help. You see a few examples and you must infer the rule. Humans do extremely well, over 90% easily, because we could see patterns, right? So like here, you see the light blue, pink and yellow, right? So obviously we see the pattern on this, right? So we see uh, here the pattern. Okay, so blue matches with these blues, right? It's the same pattern going across, but then it switches to the right hand side where you see the blue and the yellow here, right? Which is these two. It just got switched over to this side, right? And it just goes down the middle, and then obviously we still have the same box here on the bottom. So it's a pattern, and us humans actually see this really very, very easily. Some of us, and LLMs actually have a hard time seeing that. So even brute force programs score around 50%, but LLMs they score between 5 and 21%, which is very low. This tells us something important. LLMs aren't learning abstract reasoning. They're operating in a world of pattern matching, not program synthesis. If we want AGI, we need systems that solve archetype problems reliably, and we do. And once we get this, for them to actually think for themselves, it'll be beyond. It'll be amazing. So what's next, right? Building real intelligence. That's what we want to do. So ARC has done like a prize where you could win a grand prize of $700,000. I was actually reading it, and then it goes based on a team of five. Okay, so you could do this with a group, and it's pretty interesting how this thing works and what they're trying to come up with. LLMs are great at value centric type 1 abstracting. We need program centric type 2, okay, which is reasoning for true AGI. And future equals merging deep learning, intuition, and program search reasoning. So here the ARC prize is around $1 million, okay, even though it says right here, but there's other prizes that you could do like paperwork, which just gives you like $60,000, and there's other types of scores. Oh yeah, so here the grand prize is $700,000, 75,000, 50,000, and 175. So you could all get that money competition to push the frontier. So LLMs are amazing at type 1 thinking, okay, which is type 1 that we discussed here. Fast, intuitive, perception driven, but what we need is type 2 logic. This is what we need, uh, which is logic, planning, abstract reasoning. That's why the future lies in blending deep learning with program synthesis. Imagine combining intuition with step by step logic, just like we humans do. That's how we make sense of the world. The ARC Prize is challenging the research community to crack with this $1 million, more than $1 million in rewards. And interestingly, the best submissions so far aren't from Google or OpenAI. They're from individuals and outsiders. So maybe, just maybe, the next breakthrough in AGI won't come from scale, but from insight. So thank you so much. Hopefully you like my video, and I'll post more videos coming soon. So once again, thank you for your time. Thank you for everything, and thank you again. And follow my YouTube channel, Christopher Gonzalez -05. Bye.